Hello, good evening everyone. Today the third day the live session. Third day is the live session today. So up to yesterday, yes we have successfully completed motion basics related to that. Uh, Now today we will continue. Welcome to Physics Cartoon Camera. So nice to see you all the audience. As promised, Physics Cartoon Camera will teach you the basic concepts of physics of class 9 standard to 12 standard. Once completion of class 9 standard, again we'll go ahead for class 10 standard, simultaneously class 11th and 12th. So most of the time, yes, myself S.V. Raman. Voice is low. Just a minute. Yes, probably it's fine now. Hope it's clear now. Yes, students, I guess it's clear my voice now. Hope it's clear now. Yes. Welcome to Physics Cartoon Camera. This is the third session of motion chapter of class 9 standard CBSE. Further proceedings. Up to yesterday, we have studied about uniform motion, non-uniform motion, uniform velocity, non-uniform velocity, uniform acceleration. So these we studied. Hope it's fine. Yeah. Now further continuation we can go ahead. So where we are using these graphical representations, in our practical life. Probably you aware of this. While in cricket match, what is the speed of a ball and which direction it hits, how many runs. So this is the practical applications of graphical representation of motion. Now, graphical representation of a motion, there are some equations. V is equal to U plus AT. So how to derive this V is equal to U plus AT equation in a simplified way? Let's say an object starting at point A started with initial velocity U, it reached to point B, final velocity V, in distance S with acceleration A. Repeating, an object at point A started with initial velocity U, it reached to point B, final velocity V, with distance a, acceleration a, distance s in unit time t. Now, as per the definition of acceleration, acceleration is equal to rate of change of velocity, as you know that, which means final velocity minus initial velocity by time. Okay. Now, do the cross multiplication. A into t is equal to v minus u. This minus u take left hand side. So v is equal to u plus at. Hence, this is the first equation. Okay. Here u refers initial velocity. Initial velocity. V refers final velocity. A refers acceleration. Acceleration. Time t refers, this is time. S is distance. S refers distance. So V is equal to u plus at derivation proved. So further we can go ahead. S is equal to ut plus half at square. So how to derive S is equal to ut plus half at square? Let's consider x-axis time t, y-axis velocity v. Velocity v. An object at point A started with initial velocity u, it reached to point B, final velocity v in unit time t. There is unit time t. So this distance is t, which is O. Now, drag a line over here. O, let's say A, this point B, this is a C and this is D. Okay. Now, the distance S is equal to area of a triangle, area of a triangle and area of a rectangle. Area of a rectangle. So the distance S is equal to area of a triangle ABC plus area of a rectangle OACD. Now, what is the area of a triangle ABC formula? Half into base, that is AC, into height BC, plus area of a rectangle formula OA into OD, which is length into breadth, that is equal to half into here AC, which is parallel to OD. Both are on the time axis. So AC is nothing but OD, which is time t. BC, which means this height. This height how to calculate? Let's say O to A, that is initial velocity u, and O2 at point B over here on the y-axis, B will be stop over here. So this distance is final velocity. So the remaining distance V minus u. Okay. Now BC is nothing but V minus u. We need to substitute V minus u plus OA, which means the distance u, and OD time t. Now from the first equation, V is equal to u plus at, V minus u is equal to at, as we know that. So we need to substitute on the place of V minus u at. So half into t into at plus ut. That is equal to half at square plus ut. So we can write S is equal to ut plus half at square. Hope it's clear. Hope it's clear. I guess the students, hope it's clear to this equation. Yes, we can proceed. Next equation, v square minus u square is equal to 2as. V square minus u square is equal to 2as. This we will see that. While formation of v square minus u square is equal to 2as, again you can take a graph. On x-axis time t, on y-axis velocity v. An object at point A starting with initial velocity u, it reached to point B, final velocity v in unit time t. Okay, so O, A, B and this is C. S is the distance. Now S is equal to area of a trapezium OABC. Now the area of a trapezium OABC, the formula here, always remember short length plus long length, which is OA plus BC by 2 into base. Base value will be OC. So OA in the sense of initial velocity u, BC final velocity v by 2 into OC. OC in the sense of time t. So from the first equation, v is equal to u plus at, v minus u is equal to at. Okay, v minus u is equal to at. Now t is equal to v minus u by a. Substitute over here on the place of t. So v plus u by 2 into v minus u by a, which is s is equal to. So s is equal to v square minus u square by 2a, which implies v square minus u square is equal to 2as, which is quite simple and easy to derive it. Hope it's clear. Yes. We'll go ahead. Let me see what you have understood. There is a question here. Now, are you ready? Are you ready? Yes, we will see. First question. Yes, we'll see this. And a few topic is there. Uniform circular motion. What is uniform circular motion? If an object travels equal distances in equal intervals of time. If an object travels equal distances in equal intervals of time circularly, we can call it as uniform circular motion. So equal distances in equal intervals of time circularly, that is uniform circular motion. So this is the chapter of motion. Now we can see that how that CBSE questions will ask us. Yes. We will see the CBSE questions now. State the meaning of uniform circular motion. State the meaning of uniform circular motion. So how to answer this question? Just now we have discussed how to define uniform circular motion. If an object travels equal distances in equal intervals of time. In equal intervals of time is called uniform circular motion. So this is the way we have to write in examination. Next question. Why is the motion of an athlete moving along the circular path is accelerated motion? Repeating. Why is the motion of an athlete moving along the circular path an accelerated motion? So how to answer this question? Another way we can think, athlete is running in a circular path to accelerate. A reason. This is the way also the next framing of the question. For this, while in a circular track, each and every point of a circular track will change the direction. Yes, while a athlete is running in a circular track, each and every part the direction is changing. Once direction changes, he accelerates in motion. Yes, we need to write while running in a circular direction, in a circular path, each and every path, each and every point, the direction of path, changes. Okay, hence an athlete get accelerated, gets accelerated. Yes, so this is the way we need to write the answer for 1 mark question. Next question. State the type of a motion represented by given graph. You can see that there is a graph of distance time graph. So this graph will represent as if an object travels equal distances in equal intervals of time, we can call it as uniform motion. So this graph represents uniform motion. So this is the right answer. Next question. If an acceleration of a particle is constant in magnitude but not in direction, what type of path does the particle follow? Audience can answer this question. Repeating again. If the acceleration of a particle is constant in magnitude but not in direction, what type of path does particle follow? Yes, check the audience. Yes, any message from them to answer this question? We will see it. And we'll explain now. Now you can see, if the acceleration of a particle is constant in magnitude but not in direction, what type of path the particle follow? We can understand in another way. Both motion of an object at the same time, acceleration is not same. So when it is possible? We need to answer this question. Okay? We'll see. Yes, I'll say this answer. The acceleration of a particle is constant in motion but not in direction, which means the direction of a motion is something else. But acceleration will be another way. This example how to type: what type of path does the particle follow? For example, there is a stone, you vertically throw top direction. Now the motion of an object will be the top direction, but acceleration due to gravity in downward direction. Yes, an object which is moving in top direction, at the same time the acceleration due to gravity downward direction. In this case, the acceleration of a path of a particle is different than the motion of an object. This example we have to give. Next question. Next question. Yes, two cars A and B having their displacement time graph as given below. Which car has the greater velocity? Which car has the greater velocity? How to identify this? Two cars A and B have their displacement time graph given below. Which car has the greater velocity? Now you can see displacement time graph. There is A and B. You can see the B car which is having maximum displacement than A. Now once velocity is equal to displacement by time and the displacement of a car B is greater, so the velocity of a car B is greater. Okay. So the velocity of a car B is greater. Next. Next question. A particle is moving in a circle of diameter of 5 meters. What is its displacement when it completes 1.5 revolution? Again repeating. A particle is moving in a circular of diameter 5 meters. What is its displacement when it completes 1.5 revolution? Now let's see this answer. Repeating. A particle is moving in a circle of a diameter 5 meters. So there is a diameter 5 meters. When it completes 1.5 rotation, which means complete rotation displacement will be 0. And again half rotation, 1.5 rotation, which is stopped over here. Let's say point A to B. Now what is the displacement? Displacement is a diameter now. So the displacement of 1.5 revolution is 5 meters again. Alright. Once we can see the audience. Yeah, next we can proceed. Next question. What kind of a motion of a body is represented by the graph given below? You can see that there are two graphs. One is a distance time graph, other one also the distance time graph. But the first distance time graph, the line which is parallel to time axis. The line which is parallel to time axis. So when it is possible? An object position not changed but keep on time is increasing. When it happens? Only one case, if object at rest position. Second case, what it is? An object equal distances in equal intervals of time at a certain point, then object at rest. Now in this graph, first up to here there is a uniform motion, and then it will be rest position. So this the graph represents. Next. Yes. Next question. The direction in which an object moves is given by the direction of velocity of an object and not by the direction of acceleration. Give an example to justify the statement. Repeating. The direction in which an object moves is given by the direction of velocity of the object and not by the direction of acceleration. Give an example. Very simple over here. Again, we answered before. If an object vertically thrown top direction, an object vertically thrown top direction, then the moment of an object is different, acceleration direction is different. Okay, so this answer we have to give. Next question. Yes, there is something like graphical related question. Velocity of a particle moving along a straight line in a certain time interval is shown below. What is the distance traveled during acceleration? What is the distance traveled during acceleration? Now you can see that there is a velocity time graph. Velocity at 10 meters per second, time will be up to 5 seconds they given. But what is the question? What is the distance traveled during the acceleration? In this graph, where is the acceleration? Generally 0 to up to here. This path will represent acceleration. Yes or no? Now in this path, you can see that acceleration is equal to velocity by time. At this point there is an acceleration. Now here the velocity will be 10. Time will be 1 second. So finally acceleration is 10 meters per second square. Hope you understood. Next question. Next question. An object starts with initial velocity u and attains final velocity v. The velocity of object is changed at a uniform rate. Now write the formula of calculation of average velocity. Now you can see that an object starts with initial velocity u and attains the final velocity v. So what is average velocity? Average velocity is equal to initial velocity plus final velocity by 2. That's it. They're asking formula for calculating of average velocity. Next question. Yeah. A cyclist travels a distance of 4 kilometers from P to Q and then moves distance of 3 kilometers at right angle to PQ. Find his resultant displacement graphically. So once they say graphically, children has to write there is a diagram. So how the question asked? 4 kilometers from P to Q. Let's say this is P point and this is Q point. The distance between P and Q is 4 kilometers. Then 3 kilometers at the right angle to PQ. Let's say this is R point. This QR is 3 kilometers. Calculate the resultant displacement. So how to calculate displacement now? P to R. We have discussed P to R. Now as per the Pythagoras theory, PR square is equal to PQ square plus QR square. So PQ square in the sense of 4 square plus 3 square, which is 16 plus 9 is equal to 25. which is PR square. So PR is equal to square root of 25 is equal to 5 kilometers. All right. Next question. Next question. A bus decreases its speed from 80 km per hour to 50 km per hour in 4 seconds. Find the acceleration of the bus. Repeating. A bus decreases its speed from 80 km per hour to 50 km per hour. Yes, they given that initial velocity and final velocity in 4 seconds. Now for this question, initial velocity u is equal to 80 km per hour. We need to mention. And final velocity v is equal to 50 km per hour. In how much time? T is equal to 4 seconds. Now, what is acceleration formula? Acceleration A is equal to v minus u by t. V minus u by t. So A is equal to 50 minus 80 by 4, which is minus 30 by 4. So how much it is? 7.5 minus meters per second square. Yes, the students are asking email. Yes, I'm there to help you. Yes, audience, yes, my email is there under the description. And there is a Telegram. You can join through Telegram. All the notes of class 9th standard, 10th standard, 11th and 12th, I'm giving to you, my handwritten notes. You can utilize the notes. You can see the description to my email ID. Next. Next question. An electric train is moving with velocity of 120 km per hour. How much distance will it cover in 30 seconds? They will ask in a different way. So how to answer this question? An electric train is moving with the velocity of 120 km per hour. So velocity they have given. Always remember, think about given data. What is given data? Velocity v is equal to 120 km per hour. So how much time? Time t is equal to 30 seconds. Students, there is a small attention here. The units always will be in the same form. 120 km per hour you can convert into meters per second, or 30 seconds convert into hours, whatever the same. But which is easy, 120 km per hour we can convert into meters per second. As you know, 1 kilometer per hour, how many meters per second? This is the question arising by the students. Now 1 kilometer, 1000 meters. 1 hour, how many seconds? 3600 seconds, because 60 into 60. 1 hour 60 minutes, 1 minute 60 seconds. So 1 hour 3600 seconds. Hope you know this. Now finally 5 by 18 meters per second. So 1 kilometer per hour is equal to 5 by 18 meters per second. So now velocity 120 kilometer per hour convert into meters per second, which is 5 by 18 meters per second. Now the distance. Velocity is equal to displacement by time or distance by time. Distance is equal to velocity into time. So velocity 120 into 5 by 18 into time 30. So you can simplify it over here. Okay. Next. Next. Any questions? Any questions from audience? Hope everyone is clear. Next. Give one example. Each distinguish between uniform acceleration and non-uniform acceleration. As you know that uniform acceleration in the sense of velocity by time. If an object travels equal distances in equal intervals of motion, that is uniform speed or uniform velocity, what we can say. If an object travels equal displacements in equal intervals of time, uniform acceleration. If any one component is unequal, that is non-uniform acceleration. Clear? Now, explain the difference between two graphs. You can see velocity time graph which is started from origin. Okay? That is uniform velocity. At a certain distance again it is started. This is non-uniform velocity. Clear? Next. A particle moves 3 meters north and then 4 meters east and finally 6 meters south. Calculate its displacement. A particle moves 3 meters north, okay, and then 4 meters east and then 6 meters south, okay. From here to here north, quite opposite way south. So this is 6 meters. Now they're asking about displacement. So displacement in the sense of starting point to ending point over here. Let's say this distance we need to calculate. Now children will be confused how we have to do this. Very quiet and easy. Point A to point B, that is 3 kilometers. Point B to point C, that is 4 meters. And for here you can set a point over here. Let's say point D. AB is equal to CD over here. On that case, then CD also 3 meters. Now drag a line. Now BC is equal to AD, which is 4 meters. So the total distance is 3 meters. In that CD is total distance is 6 meters and CD is 3 meters. What about remaining? Remaining also 3 meters. Now, what about this distance? Again Pythagoras theory. Let's say this is E. Now, AE square is equal to ED square plus AD square, which is ED square 3 whole square plus 4 whole square, which is 9 plus 16, 25. So AE is equal to 5 meters. That's it. 5 meters. So that is the displacement. Yes. Any doubts from the audience? Probably you have understood. Yes, I committed to teach daily 10 to 11 p.m. Physics cartoon camera will help you that academics of class 9 standard to 12 standard for board examination. After completion of class 9 standard, I'll go ahead with class 10th, further class 11th and 12th classes. So there is a customized presentation, and as per the CBSE, we'll go ahead. Later years, I'll start with icse. Thank you so much for attending of this session. And if you have any queries, under my description, there is an email. You can ask me the questions. And who are not subscribed, subscribe the channel. You can get immediate notifications daily 10 to 11 p.m. Thank you so much, audience. Bye for the day. Good night. Jai Hind.